So we have this here, and pretty difficult looking diagram, and for somebody like me, I generally make it a lot bigger, and it helps me see what I'm doing. So you are going to be absolutely massive. Alright, now first thing we're going to write down our target. We're looking for AOC. Now AOC, I can write that down as 23 degrees, and I'll explain why. It's standing on the small arc AC. Does that make sense? Oh, no. Can't write it down as 23. It's actually 46. It's double the other one. Because they're standing they're standing on the same arc, but one of them's on the circle while the other one's at the centre of the circle. So that's 46. Is that alright, start off? Yeah, we'll just chill for 1 sec, 'cause I think Charlie has a question for me. So Charlie, that one is standing on the arc AC, and it has a point B which is also on the circle, while AOC is at the centre of the circle, standing on the same arc. By that rule, it's twice the angle 23. Go for it, Charlie.
Is there any way to prove that ACB is 90?
I'll look for it now, just give me.
It looks like it's 90, and if you let it equal 90, you can get AOC a different way.
Just let me have a look at it now, okay? So which angle did you want? ABC, or was it?
ACB.
ACB. No, there's nothing to say that that's 90.
Okay. Because if you let it equal 90...
Yeah, no, it could be just a coincidence more than anything, Charlie, but you're not allowed to let that equal to 90 for any reason. I'm still looking. Yeah, I'll be with you now. Okay. Now it says OA is parallel to BC. Is that alright?
Yeah.
So what Connor then jumped on is that's 46, because it's alternate, isn't it?
Yeah.
So OXB. So OXB is also 46, is it? And then OCA. Where's OCA located? OCA. That one there, alright?
The first one isn't.
Sorry, sorry, no, it's not 46. Yeah, thanks. Working on it, relax, we'll get there. Right, that's 46. And then, what's this one here?
You can also break up the 23.
I'm just focusing on what I'm doing, alright? Unfortunately for me, I can't take many different ways into consideration at once. Not smart enough, to be honest. Alright, so what's this? 111? And what's 111 from 180? That one will also be 69, and that one will also be 111. Did I find my answer yet? OXB 69?
Yes.
Perfect. Charlie?
I did it a different way. I said that because AO and OB are both going to the centre, they're the same, the two radius. So it means
Isosceles triangle.
OIB is isosceles, and because the angle at D there is 23, the ultimate angle on the other side at OA
23 and that's 23 as well.
The two are 23 there.
Yeah, gotcha. Yeah.
This works out.
I'll probably use that in a second, maybe. So look, guys. I think what we said is this is Charlie said that OB and OA is a isosceles triangle.
Yeah.
And 23 is alternate to the other 23, but because it's isosceles, that will also put that as 23 as well, which is just lots of extra information.
Then that the angle at O is whatever's left over, which is 134.
Alright, so just chill for a sec. So this angle, I'm going to get this green angle here first, alright, and I'll add them both together.
Well, no, I did is I found them both together first, and then subtracted 46 from it.
Yeah, I'm just concentrating on what I have on the board so the lads can follow it. You get what I'm saying? So, can you do 69 plus 23, take it away from 180 for me?
You get 88.
88, thank you. Alright, and what are we looking for? OCA, we're looking for this one here, aren't we? Now, what else can we go for here? We're missing something. Oh, there's another isosceles. No, that's 46.
Sir, OA and OC are also the same.
OA and OC, that makes that an isosceles triangle. Oh, we have enough then, yes. So lads, look, just keep looking. See those two black angles I just drew? Everybody see them? That's 46, and those two black angles are isosceles. So what happens when you take it away from 180 and divide by 2? What you get, Charlie?
67.
Or other Charlie apparently. Divided by 2 is 67, is that right? So that'd be 67, which is OC. A. Yes, sure.
I did it a different way.
Did you get the same answer?
I think so. I think I did it wrong, but I did it a different way because I took like the two angles. From
So, in a way, I'll just rub it all out for a minute, okay? So, I think what we said earlier was, okay, so if I just fill a few of these out. Oh, yeah. See the way it's standing on the arc AC? Yeah? And see the way it goes to the centre of the circle?
Yeah.
And see the way this angle here, the 23 degrees, it's also standing on AC, but its point is actually on the circle. That rule means that the one that's at the centre of the circle is double it
Right.
to get you 46.
Yeah, okay.
Alright, now if you aren't, the rule usually looks like this, alright? It's usually a lot easier looking, as in it's usually, it's usually this. That's 100 degrees, and then you go, oh look, the one up here is 50. It's that rule. It's just that the point is pulled over to the right.
Yeah.
It makes it look weird.
Right.
Okay, any other questions? We good? Alright. You can close a window or two if you're cold there in the corner, because we're in the green, so we have a bit of flex. Alright guys, you ready for 34? Alright. Now 34. Alrighty. Here we go. The centre of the circle is O. AOB is 130. So where's AOB? 130. Alright, it's the same trick again. What's AOB standing on? Would you agree AOB is standing on the small arc AB? And what do we notice about this angle here? It's on the same arc, but it's on the circle. So what do you think the answer is, Sam?
Half 130.
Which is 65. We cool with that? Alright. Now next thing. It gives me another piece of information. CAO. Where's CAO? 15. Alright, we have this under lock now. 180 take away 130 take away 15. What? 35. And then fairly opposite, we'll put that at 35. And then that's 90 degrees then, isn't it? No, it's 100 degrees.
Yeah, so 80.
And OBC will be 80. We cool with that? All good? Alright. 35. Diagram seems a bit nicer in this one. Okay, once again, just going to copy and make it extremely large. Alright guys, now the angle SOQ, where SOQ is obtuse. SOQ. Alright, it wants this one, it wants the red angle, which is between 90 and 180, and it doesn't want the blue reflex angle. Do you get what I'm saying? I think we can all agree that that is 124.
Yep.
Because it's twice the angle on top. It's standing. They're both standing on the arc SQ. Is that alright? Now, likewise, there's a cheap way of doing this as well. We can get the reflex angle. So, what's the reflex angle?
360 minus 124.
360 minus 124.
236.
What?
236.
Yeah. Now, do you know when you were doing this in your junior certs? Anything you type into your calculator, write it down on the page, because you want to show workings just in case it goes wrong for you, and then the examiner can follow what you're doing rather than just filling in all the angles like I am now. Do you get what I'm saying? Anything you put in your calculator, type it out, write it out. Okay? Now, that means what this angle here is what?
118.
Half the 236.
Yeah.
They're standing on the major arc, aren't they? So that is, what's a 118?
Yeah.
Happy days. Now, okay.
Like half the answers now, basically.
What?
That's basically most of the answers.
Oh, what am I lacking now? So what's that? That's 124, 236, SRQ,
118.
118, SRA,
118.
S to R to A. Oh, that's handy enough. 180 take away 118 take away 28, which is
34.
24. Happy days. We all good? Alright. Oh, look at that beautiful diagram.
Sorry, sir, what was the answer for the last one?
34.
Yeah.
Okay. Next one. AB and AC are tangents to the circle B and C respectively. The centre of the circle is O and D is the point on the circle. If angle BAC is 30 degrees, find BDC. Oh lordy. Oh, this is interesting. Alright. I think I have it. Alright, here's what I'm thinking, and here's how I came up with it, okay? What was this full chapter has been very much about this one here being half this one here. Does that make sense?
Yeah.
So for some reason I decided that my attack was going to be based around this. Do you remember I said to you the other day, sometimes you see and sometimes you don't. This one I saw in 2 seconds. One of you guys could be in my position where you're not seeing anything. Alright? Now here's what I'm thinking. I'm thinking I make this angle straight down like this. Alright? And here's what I'm next thinking. What are we doing here? So that's 90 degrees. Does it say anything about lengths being the same?
Is it not 90 degrees before you do the line? But it's
Sorry, this part's 90. That's 90.
yeah.
And therefore, inside 90 as well.
That's 90. And how do we relate that 30? Just 1 second. Go on, Cherry, have you thought this one through yet? Yeah. So when I came up with that idea, sometimes you do it, then I realised this idea is completely wrong. Park it off. And what the lads are saying is that, look, this is 90. That's also 90. Agreed? And that's actually a quadrilateral. So this blue angle here has to add up to 360 when you add it with the 2 90s and the 30. So 360 take away the 2 90s and take away 30, and what you get?
150.
Which is 210, is it? And then half of 210?
Oh, 150.
Oh, sorry.
That's 150.
Sorry, 150.
The angle that was 150.
And then that's 150. And half of 150? 75 is our answer. Is that okay? Okay.